Okay, so for number one, it says complete the table for the function f of x equals 2 to the power of x. So if I go to this table, 2 to the power of negative 2 equals what? 0.25. 2 to the power of negative 1 equals what? 2 to the power of 0? 1. 2 to the power of 1? And 2 squared? 4. Then it says reverse or flip the coordinates and enter them into table 2. So, like I was saying, the log is the opposite of exponential, or it is the inverse, which if you remember, whenever we talked about inverses and we were dealing with the table, all we had to do was we made the y's the x's and the x's the y's. Okay, and like I was already saying, the relationship between those two tables is that they are inverses of each other. Alright, so next, come down here and let's graph these two. So take that first, table 1, okay, and graph those points down there. So you've got negative 2, 2.5, negative 1.5, 0, 1, 1, 2, 2, 4. If I was to take that to the next one, 3 squared, or sorry, 2 to the power of 3 is 8. Okay, and then I will do the table 2. And I've got 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, 4, 2, and if I use, then I could also have that 8, 3 value. Okay. Which, going back from talking about the inverse function, whenever we had those on the graph, what line did it reflect across? The y equals x. So go ahead and draw that line on there. And you can see that it reflects across the y equals x line. So over here again you can put that they are inverses of each other. Because they reflect over y equals x. Alright, going down to this little diagram right here. And there's another one with a little more space on the back. Sorry, no, this is where it's at. Let's just talk about some basic properties. So, that statement right there, the inverse of an exponential function is a logarithmic function. The inverse of y equals 2 to the power of x is y equals log base 2 of x. Make sure that you memorize how to say that. Log base 2 of x. Okay? So, whenever you do this, you can rewrite exponential into logarithmic. Kind of like how we had the radical, the square root stuff, and we wrote it with a rational exponent, and it equaled the same thing. Same idea here. Okay? And you just you got to know what goes where. The base, this is the base, and that's why over here, that's why we say log base b. Okay? Then you say of a, and then, of course, equals x. Now, there's another way that you can remember this. Okay, and it's what I call fish hook, just because if you follow the path, it looks kind of like a fish hook. So, one, you got to know that if you're going from exponential and you're going to logarithmic, the first thing you have to do is write log. It's not logarithmic form unless you write log there. Alright, you always start at the base. Okay, so log base b. You go across the equal sign. So log base b of a. And then you come back where x is. Okay, and again, you will hear me refer to this as fish hook. Okay, and I think some teachers say it's scorpion or something because it looks like a scorpion tail, I guess, but I'd rather fish. So. Also know that if you're given logarithmic, and you're going to run into this, if it's in logarithmic form and you got to go to that, you can fish hook it to go back to exponential too. Okay, and it's very similar. Do the same thing. Start on the base. Okay, there's my base. I go across the equal sign. So b to the power of x equals a. And it still has that kind of fish hook pattern. And I'm just going from exponential to log back to exponential. It's the same thing I started with. So whenever you're asked to convert it from one to the other, that's all you're going to do. It should be pretty simple. Okay? Alright, we're actually not going to do 2. We're going to go on and we're going to practice doing that exact thing. Okay, so going through this one first, going from exponential to log. So on that first example right there, case, what is the base on that? 3. So I'm going to have log base 3. What would be of what?
244
Equals?
5.
Awesome. Whenever you're writing going from from log to exponential, it's always going to be equal to what the exponent was in the exponential form. Okay? So Tanner, what would the next one be?
Log 25, right?
So am I going to write it like that?
No.
Okay. What do you need to say before you say the number 25?
I don't know.
Sierra? Log base 25 of what?
5
Equals?
equals 1/2.
1/2. So say that whole thing correctly.
So log base 25
Log base 25 of 5
Oh, of 5, yeah, that's right.
equals 1/2. Callie, what would the next one be? What? Log base 10 of 10,000 equals what? 4. Jacob, what would the next one be?
Log base 6. 1/6 equals 1.
Log base 6
Negative.
of 1/6 equals -1. Jade, what would the last one be?
Log base A of B equals C.
Log base A of C.
Oh, okay, yeah.
Equals B.
Never mind. I got them messed up.
Okay. So now I go over to going from log, and I'm going to go to exponential. I can still do the fish hook, and I always need to start it on the base. Okay, so this first one, the base, which this is a little confusing because there's 2 9s, but it's that little 9. So this would be 9 to the power of 1 equals 9. Alright, Journey, what would the next one be?
2 to the power of 9 equals 12.
Okay. Ray, what would the next one be?
8 to the power of 1/3 equals.
Awesome. Spencer, the last one.
4 of the power of -2, or 2 to the power of -2 equals 1/16.
Fabulous. Okay, so you need to know how to go from one form to the other. Okay, I haven't looked over the homework very heavily, but I would imagine this is one of those homeworks where there's probably a big chunk of them. Let's see. The first 6 problems are going from log to exponential. Okay? And it's just that, so that should take you just a couple minutes to do that once you get the homework. Okay? So there's certain properties that it just makes life easier if you memorize them. If there's a certain number in a certain spot, you'll always know what the next, you should be able to solve it pretty easily. Okay, so if I write these exponential forms into logarithmic, Casey, what would the first one be?
0 or log base 0.
What's the base over here?
Oh,
4
4.
of?
1 equals 0.
Okay. Bill, what would the next one be?
Base 10 of 1 equals 0.
Okay. Eden, last one.
Log base 0.5 of 1 equals 0.
Okay. So, does anybody notice a pattern there? Do what?
Of 1 is 0.
Anything of 1, okay, log base, I don't care, it doesn't matter, of 1 is always going to be 0. Because anything to the power of 0 is always what? 1. Okay? So, and we've talked about that property, remember? That should be the easiest exponential property there is. Exponent of 0, it equals 1. I don't care how big this base is. But because these are inverses of each other, there's similar properties that we can use in logarithmic, and it's log base I don't care, of 1 is always going to be 0. Okay, so if I go up to the top there, and I put these logarithmics into exponential, Sam, what would that first one be?
4 to the power of 1 equals 0.
Cam, what would the next one be?
10 to the power of 1 equals 10.
EJ, what's the next one?
0.5 to the power of 1 equals 0.5.
Okay. So, really looking more at the logarithmic side of this, what's the pattern there?
They all equal like each other in the like.
So the base and what is called the analog, which is this. Okay, if those are the same, it's always going to equal 1. Okay. Or sorry. No. It's always going to equal 1. Because anything to the power of 1 is itself. Okay, because of that, we can also have that logarithmic property that if we memorize, it just makes life easier. Okay. Alright, so let's go to the back here. Let's see what all we remember from our exponential stuff. So, my exponential, which is this graph right here, the stuff we just got done talking about on that last test. What is my domain for that? All real numbers. What would the range be for the parent function there? 0 to infinity. And what is the horizontal asymptote? Y equals 0. Okay. So if whenever we had that table on that first page and we just switched all of our x's and y's, that means the domain and range switch. That means all the information that we have on it switches. So which one of these is now going to be all real numbers? Range. And the domain is now going to be what? 0 to infinity. And my vertical asymptote is going to be what? X equals 0. Okay, so now we had horizontal asymptotes. Now we're going to have vertical asymptotes. Make sure that you're good on this. The range is all real numbers because this is going to go down forever. This is going to keep climbing up forever. But the domain is 0 to infinity. Obviously, it's easy to tell the infinity part. That's going to keep going to the right. This is never going to be on the left side of the y-axis. It's going to go right down that vertical asymptote at x equals 0. Okay. Whenever we talked about the horizontal asymptote on logs, whenever we looked at the equation, how could we easily find the horizontal asymptote by looking at the equation? Well, it was always the what? The d value, right? Because the d value, think of that as what moved that horizontal asymptote up and down, right? Okay, the horizontal asymptote is what moved up and down. A vertical asymptote is going to move which two directions? Left and right. So whenever we talk, and this is kind of foreshadowing, we will talk about this, but what transformation, what letter, whenever we talk about transformation, moves the graph left and right? The c value. So whenever you look for the vertical asymptote on this, you're going to look at the c value. Minus 2 moves it to the right 2, so it's x equals 2. Okay, so there's a few similarities between the two, just few little tweaks. What do you notice about it? Just all the information is switched. So next, let's go through this graph. So we'll have an exponential. We'll graph it. We'll find the inverse of it, which will be in some kind of log form. Every inverse of exponential is going to be log. Every inverse of log is going to be exponential. And then we'll graph that log equation on there before we go on to the bottom part. Okay, so first let's fill out that table. 3 to the power of negative 2 is what? 1 over 9. Remember, if you have the negative exponent, remember that all that does is it makes it a fraction. If 3 squared is 9, 3 to the power of negative 2 is 1 over 9. If 4 squared is 16, 4 to the power of negative 2 is 1 over 16. That's all it does. So 3 to the power of negative 1 is what? Do what? 1 over 3. 3 to the power of 0 is what? 1. 3 to the power of 1. 3 squared. Okay, go ahead and graph those for me. Okay, so what's the domain of that graph? All real numbers. Sierra, what is the range?
0 to 1.
Jacob, what is the horizontal asymptote? Okay. So, whenever we're having to find the inverse of this, let's kind of remember some rules on doing this. And I'm going to do this all over here on the margin so that I can make it large, but make sure you got plenty of space to write this. Okay, so if I'm finding the inverse of this, somebody remind me. What's the first thing I do if I'm finding the inverse of something? Do what? Yeah. Flip the x and the y. So I'm going to have x equals 3 to the power of y. Now, whenever it's written like this freaks a bunch of people out. Whenever the base and the exponent is on the right. Because whenever I showed you to do fishhook, it was always base on the left and fishhook. Base on the left and fishhook. Okay? Well, if you've ever actually held a fishhook and you just turn it around, it can go the other way too. I don't know if you know that or not, but that's a great thing about three-dimensional objects. But if that freaks you out, the part that has the base and the exponent, just write it, just flip the whole equation. And that way you're fishhooking the same way every time. From left to right, back to the left. But you've got to remember to put that base and exponent on the left. Okay, so now if I'm here, Rissa, and I take that and it's an exponential form and I write it in log form, what is that log form going to be?
It would be 3.
Now, if I'm writing in log form, what do I have to write first?
Oh, log.
Log. So log
Log 3.
base 3 of
X.
equals. Okay. And then again, if you don't like that, I would probably write it, flip it so it's y equals. Y equals log base 3 of x. Now, These x values are going to be the what values of the table above. The y values. Remember, x's and y's flip on the table. So I've got 1/9, 1/3, and so on. And then go ahead and graph that. And Rosalind, if those two graphs are inverses of each other, what are they going to reflect across?
Is it the x side, or the y equals x?
Yes. EJ, what is my domain going to be on this?
0 is probably
Larkin, my range.
Negative 3, positive 2.
Tanner, my vertical asymptote.
y equals 0, or x equals 0.
There you go. Vertical is going to be x, horizontal is going to be y. Okay, so whenever you're doing this, and a lot of you can tell me that 4 squared is 16 and all that easy stuff dealing with exponents, but you kind of have to change how you think about it whenever you're doing simple logs, okay? And it's not very difficult. Whenever you do this, the way I think of it is, again, you're starting on the base, and you're going to follow that fishhook pattern. 5 to the power of what equals 125?
5.
No.
2.
No. 5 to the power of 2 is 25. 5 to the power of 3 is 125. Okay? 25 times 5. Okay? Think about it. That's log solves for the exponent. Okay, 5 to the power of what equals 125? 5 cubed is 125. Okay? 10 to the power of what equals 1,000? 3. Because 10 squared is 100. So if I do it times 10 one more time, that's going to give me 1,000. 12 to the power of what is 12? 1. We'll save G for here in a minute, because that one's always interesting. 3 to the power of what is 81?
4.
Doing this without your calculator. Oh. 7 to the power of what is 1? 0. Anything to the power of 0 is 1. Alright, now think about this one. 2 to the power of what equals 1/2? Negative 1. Because the negative exponent is what's going to make it that fraction. And then 2 to the power of 1 is just 2. 2 to the power of what? Write that out here. Equals 1/4. Negative 2. So, coming back over here, 10 to the power of what equals 0.001? Do what? What'd you say? Somebody said -3. Okay, that one is obviously the more difficult one. All right, last little thing, and it's getting into that. At the beginning of class, I told you that the little calculator, or the little LN button, we're going to be using that, and I'm going to talk about that. But you do need to know this. A logarithm with a base 10 is called a common log. Okay, so if it's just log and there's no base, there's that understood 10 down there. For example, log 5 equals log base 10 of 5. Okay. Now, if you remember, whenever in the exponential unit, we had a pert, right? So we had that e, correct? So whenever you have that base of e, because we had e to the power of something, that's when this natural log, you'll use natural log if you have e. Okay, so if you have, for example, natural log of x, whatever, that is an understood e down there. Okay, sorry. It's log base e of x. Those two are the same things. Okay, and that is again what is called natural log. Okay, we'll run into that a little bit. You will see that on your homework. I'll go ahead and tell you that. You're not actually you're just getting used to using the calculator. Some of the stuff on here, because you've probably never really used the log or the natural log on the calculator, you're just kind of plugging it in there, getting used to using the log and natural log on your calculator. Okay?